In June of the year 1783, the people of southeastern Iceland began to feel the earth shaking. Over the following weeks, the quaking grew stronger. Observers recorded a darkening of the sky, a dimming of the sun, and a fall of black ash. Throughout the summer and into autumn, Iceland's long, lucky fissure tore itself apart with violent tremors, with an outpouring of lava, and with explosions of toxic gases and poisonous dust. Over the next year, most of Iceland's livestock, and maybe a fifth of its people, perished in what was to be called the Famine of the Mist. The consequences of this eruption went well beyond Iceland. Particles spread high into the atmosphere, cooling the earth and affecting weather patterns around the world. Famines, as far away as Egypt and Japan, have been linked to its effects. A curious public in Europe marveled at the strange dry fog and at the reddish glow of the sun. Its scholars struggled to make sense of the hot summer in 1783, and then a freezing winter in 1784. They even speculated on possible connections between that weather and some distant volcanic eruption. The Lackey Fissure eruption and its aftermath was only one episode in a long, so-called Little Ice Age, a period of cooler climate that stretched over centuries. In the following lessons, we'll explore what the Little Ice Age meant for the Nordic people, how they suffered and how they coped, how they adapted and changed, and what their stories might mean for us today as we face global warming. The story of the Lackey Fissure eruption illustrates themes that we'll see throughout this history. The challenges of cold years and of changing seasons in the Nordic countries. Connections between local and global climates and histories. Evolving knowledge about climates and adaptation to climatic challenges. But first, what was the Little Ice Age? How do we know when it was warmer or colder in the past? And what might it have to do with volcanoes? For over 2 million years, the Earth has moved back and forth between long cold ice ages and shorter, warmer, so-called interglacial periods. Some glaciologists in the 20th century observed that even during the interglacials, there were times when the glaciers around the world were still growing, and this suggested relatively colder periods. They called these periods Little Ice Ages. Eventually, scientists adopted the expression Little Ice Age to mean just the most recent time of slight global cooling from around the late Middle Ages to around the mid-1800s. So that makes this the most recent period we have encountered of climatic change before current man-made global warming. The advancing and retreating glaciers can offer a dramatic illustration of past cooling and of present warming. But scholars have also found many other ways to reconstruct variations in temperature and in precipitation over the past. To understand these methods, let's just take a look outside. Now, looking outside, imagine all the ways that the weather might be leaving traces in the world around you. Is rainfall gathering in the ponds? Are lakes or rivers thawing? Are flowers opening in the spring warmth and spreading pollen? Or else, are people out buying winter coats? Are they at home, turning on their saunas? Or are they on their phones, complaining to friends on social media about the cold? Some of these effects will leave measurable traces for generations, or maybe even centuries from now. Bits of pollen in the soil, sediments gathered at the bottom of lakes, variations in the growth of plants. Perhaps we'll even find records of coat receipts or utility bills, or maybe those social media posts about the weather. When some of these traces are accumulated and stored away, whether by natural processes or else by human action, they can become so-called archives of climate information for future researchers. Natural archives may include stalagmites in caves, or ice cored from the polar regions, or the growth rings that we find inside trees, and even the shells of giant clams on the seafloor. Now, archives created by people are even more diverse. They include weather diaries, records of the freezing and opening of harbors and rivers, notes in the margins of almanacs, dates of grape and grain harvests, or changes in fashion, and many more records besides. Small variations in records like these can serve as so-called proxies, that is, indirect indicators for past weather and climate. In the Nordic countries, for example, wider growth rings in trees usually indicate warmer summers. When the ports were closed due to ice, this almost certainly meant that there were colder winters. With this kind of information, we can reconstruct not only big changes in climate over the long run, but sometimes local variations from season to season. This information helps us understand the human dimensions of past climate variability and its changes, its impacts and its influences on economies and cultures and societies. More precise reconstructions, so-called high-resolution reconstructions in the words of scientists, can also help us understand what the Little Ice Age was and, importantly, why it happened. These reconstructions reveal that the Little Ice Age did not happen everywhere and in the same way or all at once, nor was it cold all of the time. The weather and seasons still changed, so summers were still relatively warmer than winters, for instance. Some years were warmer than others, and some years were colder than others. Most people at the time weren't even aware of living in a Little Ice Age, the way that we understand now that we are living through global warming. Yet, over the whole era, it was on average a little cooler than before. That's mostly because the really cold years were more extreme and were more frequent. Some exceptional decades also stand out in temperature reconstructions for the Nordic countries. These include the 1450s, the 1590s and 1600s, the 1690s, and the 1810s. So what was happening to climate during the Little Ice Age? Well, in the very long run, over thousands of years, summers in the Northern Hemisphere were probably getting colder due to tiny cycles in the Earth's orbit. This cooling may have been slowly taking the planet back towards another big ice age, but it doesn't explain the really cold years and cold decades of the Little Ice Age. The sun might have played a role too. In the late 1400s, the late 1600s, and early 1800s, we had so-called sunspot minima, which meant that just a little bit of less solar energy was reaching the Earth. However, it seems the leading cause for Little Ice Age cooling was almost certainly volcanic eruptions, like that Lackey Fissure eruption in 1783. These eruptions could eject sulfurous gases high into the Earth's atmosphere. Up there, they interacted with water vapor to form aerosols. These aerosols reflected the sun's rays or radiation, leading to a few years of cooling at the Earth's surface. Climate scientists have compared temperature reconstructions based on tree rings with precisely dated traces of volcanic eruptions found in ice cores. They have found that almost all of the coldest years, and especially coldest decades in the Northern Hemisphere, followed large volcanic eruptions. So the Little Ice Age was above all a time of more frequent, large volcanic eruptions with cooling effects. This volcanic cooling could also affect atmospheric circulation, that is, to change weather patterns around the world. Climate scientists are still working to understand which weather systems were affected and how long the effects of volcanic eruptions might last. For example, volcanic eruptions probably influenced the El Niño Southern Oscillation, patterns of winds and surface temperatures across the Pacific Ocean, with effects around the world. But it's not certain just how volcanic eruptions affected the El Niño. For the Nordic countries, an important question is whether little ice age eruptions could have affected ocean currents in the Nordic regions as well. Nordic countries enjoy relatively mild climates compared to their high northern latitudes. Now that's largely thanks to their maritime climates and to the warm North Atlantic current, what we sometimes call the Gulf Stream. The Little Ice Age, then, is not an easy thing to define. It was not an ice age when mammoths roamed Europe and the Nordic countries were buried under deep glaciers. It was, on average, just a little cooler than in the time of the Vikings, and at least 1.5 degrees centigrade cooler than at present. Some periods and places cooled more than others. Yet the Little Ice Age was not just about the climate itself. It was also about the people. In the coming lessons, we'll see how climate variability affected people's lives and livelihoods, how cultures tried to make sense of the changing seasons, how states and societies struggled or adapted in the face of climatic challenges, how the history of the Nordic countries was shaped by these experiences, and what that might teach us today.